Thomas Messerschmidt, ladies and gentlemen, with the robo navigation via sending photos to an LLM.
Yeah, let me share this screen. Navigation by sending photos to an LLM AI, specifically ChatGPT for Omni. I'm Thomas Messerschmidt, and I put together this presentation with a lot of help from ChatGPT. Right now, we're going to be exploring the intersection of robotic navigation and large language model AIs. So why? Why would you want to navigate with an AI? Well, current robot systems, navigation systems, they require thousands of lines of code, ultrasonic sensors, LiDAR sensors, bump sensors. They got to locate the robot. They got to integrate sensor data. They have mapping algorithms and decision-making code. This is a lot. But what if? What if you could just ask the robot to go anywhere? So the goal was user asks the robot, and I mean verbally, to go to a location, let's say in your house, and the robot goes there, navigating by way of an off-the-shelf large language model. So the mechanisms of operation and implementation are this. I start with a robot base, and this is just a Roomba. Sorry, Camp, it's a Roomba. And
I like Roombas. I'm a big fan of the Create 3.
all right. And I've stripped it out of everything but the motors, the drive motors. And I threw an Arduino on top of that and threw a laptop on top of that with a built-in camera and microphone. And then through the magic of Wi-Fi, we connected ChatGPT 4.0 with photo analysis. So this is the high-level flow chart. The robot sends a pre-prompt to the LLM with the communication protocol. You got to know how you're going to talk back and forth. What means what? Simple enough. The user asks, and I mean verbally, to go to a location. The request is turned into an audio file and then uploaded as text to the LLM, although ChatGPT can take audio files. That's later. The robot takes a photo of the room and uploads it to the LLM. The robot asks the LLM if it has arrived at the proper location. The LLM says, well, yes or no. Yes, hey, we're done. No, we're going to get the speed and direction that we have to go from the LLM. The LLM then sends directions to the robot. The robot relays the information to the Arduino, and the Arduino then moves the robot as instructed. In other words, the pre-prompt is set. Can you see my mouse pointer?
Yeah.
Yes.
Good. The pre-prompt is set. The user asks the computer through the microphone on the laptop, or you can use a Raspberry Pi, to go to a location. The request is turned into an audio file, then a text file, and goes back to the LLM. The robot then uses built-in camera to take a photo of the room, uploads it to the LLM. The robot asks if it's arrived. If not, the LLM then sends a response. If it's at the location, of course, we're done. If not, sends directions, says go left, right, forward, backwards, whatever. The laptop relays the commands to the Arduino and then the Arduino to the motors. And the Arduino moves the motors as, and the robot, of course, as instructed. And we start over at step 4. So some of the challenges and limitations I've had with this were windows and mirrors. It had a hard time differentiating between windows and mirrors and whether there was a hallway there. And I identified to that. I've walked into more than one mirror in the middle of the night, especially those floor to ceiling mirrors. So I'm right there with the robot. Can't tell its left and from its right sometimes. And you know, my wife's just like that. She tells me left, turn left, and it should have been right, or she tells me right, and I should have gone straight. Well, you know. So that's just right along with people. It's not better than people. That's the point I'm trying to make. It doesn't know its own size, like a lot of people I know.
That's called body awareness.
I know. I told it was about 1 foot across, and the doorway was 3, and it said, "Sorry, I can't get through there." Another limitation is waiting for commands. It'll just sit there. It won't do anything. It's not proactive. So I'm going to have to come up with some extra code to keep prompting it to decide to go forward or send the commands. And then there's latency. Each photo takes 1 to 5 seconds, sometimes 15, to upload through the Wi-Fi. And that can be very difficult if you want your robot to move faster than, let's say, one of those rovers on the moon. Those move pretty slowly. Another one is bumping into walls. Everyone who has one of these robots knows all about that. Another one is busting through walls. If your robot's big enough and heavy enough, you're going to bust through the wall. Another problem I had is inconsistent results. Yesterday's results are not today's results. Sometimes I don't get the same results I got yesterday. But LLMs, large language model, artificial intelligence systems, are continuously, constantly, continually improving. What didn't work a week ago is working today. What didn't work a month ago is working this week. So what worked? Well, without any training from me, these things had a lot of training, but I had nothing to do with it. AI, and I'm talking about ChatGPT Omni for Omni, O for Omni, it knows what a typical room looks like in a house. It knows the kitchen from the living room, from the dining room, from the bedroom, from the foyer, or foyer, if you might. It knows if it's in the same room after changing locations. It knows what part of the room it's in. It can identify many more objects than any other AI ever could. Doorways, tables, chairs, plants, people, animals, lamps, knickknacks, shelves, electrical sockets, and it goes on and on. I haven't found an end to this. TVs, it can tell you what's on the TV, what's playing, nearly everything in any room. AI can correctly tell if a door is open or closed, almost 100% of the time. AI can tell if its path is blocked, usually. So a little demonstration here. I was going to record a video and found out I can't record a video on my phone if I'm using ChatGPT. So we're going to do a live demo here.
Mic test. Oh, can you hear us?
We hear
Yes.
you.
So, anyone have questions? Feel free.
I'm not finished yet.
Sorry, go ahead.
All right. So we're going to look at my phone and we're going to just do some real-time demoing, and it may or may not work. So let me switch the camera here. Can you read that, or is it backwards?
That's good. We can read it.
Oh, it's fine.
Oh, all right. Looks backwards to me. Oh, that's because I have my own video backwards. Okay. So this has 3 modes. The first mode is text mode, where I would type things in, tip, 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 tip with my fingers, my fat fingers. The next mode is audio mode, where I hit the little microphone. And the next mode is an interactive audio mode where it's constantly listening. For now, we're just going to use the text mode. And I'm going to upload a photo. These are ones I got earlier just for our presentation here. I'm going to give it the prompt. You're in a house, comma. What room are you in? What do you see? What? One 1,000, two 1,000, three 1,000.
5 1,000.
You look like you're in a living room, an open concept space that combines a living area with a workspace or dining area. And it does. That's very correct. A white marble or stone countertop in the foreground. That's a table. Various items like flashlight, notes, a pen, a plant, and some cables. That's true. A laptop. That's true. Obscured by a plant. Sitting area. Chairs, tables, stack of books or papers, a couch with a blanket, large windows, or sliding glass doors. See, that's the door window thing. Revealing a sunset sky and palm trees outside. Yeah, I'm in Southern California, right? A table, some cluttered tables, and on and on and on. And it even gives the analysis. It looks like a cozy but somewhat messy area. Oh, come on. This is live, guys. All right, let's send it to the next picture.
So is the concept you've driven your robot around and he knows that there are these different rooms, and then you could maybe program it to go to a room? I don't understand how it's navigating.
You're going to tell it go to the kitchen, and it's going to go until it finds the kitchen. This is
Gotcha.
zero.
Okay. Okay. I get you. I get you.
It's like a stranger going into your house and finding your kitchen without knowing even where it is.
I understand. If it could explore the room and it recognizes the rooms, you're on your way. At the very least, this solves the kidnapped robot problem.
Need a map.
So, quick question. Are you using the API for the robot side when you actually do this?
Yes, I'll be uploading from a Python program. Python will talk to both the API and the Arduino for the control of the motors.
Cool.
The code is not finished yet. I've got it in bits and pieces finished. Tune in next month for the full code, I hope. All right.
Okay.
So let's see.
What would you say the overall success rate of this is for the robot navigation?
Depends what you mean by success rate. How are you defining that?
Gets to the goal without crashing into something or getting stuck?
I haven't gotten that far. I'm still got only little bits and pieces working at this point.
Okay.
Does it head in the right direction?
Yes, and for blind people, this is a godsend. One might want to add something like this to his smart cane.
What robot are you using?
Oh, well, I'll show it to you. It's right behind me. Oh, it's upside down. Let me flip the camera around. There we go. So there's your tray to hold the laptop. It's on this tripod, which is attached to the robot. That's just the table there. And your Arduino is going to run on top. It's right there.
That's nice. That's nice.
Yeah, that's a good solution.
Hey, it works. I found out this tripod has these little rubber cups at the bottom. It came with them, and I just pulled out the little balls there and put screws right into the top of the Roomba. Very convenient.
Do you call this
Anyway.
Skynet? Do you call this Skynet or ceiling net?
I don't know. We'll call it something. So the question is that I want to ask the large language model, ChatGPT, are you in the same room? So let's ask it that.
Did you
Are
want to
you in
show
the same room?
Did you want to show your screen or how do you want to do that? Yeah, okay. It's upside down.
Yes. And it tells you the matching elements.
Okay,
So
so
let's up-
different location in the room, but it recognizes that it's in the same room.
Yes, let's take a step further. And this is facing the opposite direction from the opposite end of the room. Are you in the same room? 1,000, 2 1,000, 3 1,000, 4 1,000.
Hmm.
Do you see the entrance door? And if so, is it on the left side of the screen or on the right side? Left side. Is it on the
Very
left?
Very nice.
It is.
Excellent. Thank you
It's
very
not always
much.
correct.